Welcome to this video on geometric optics. This problem set includes one problem, their learning outcome, and detailed solutions. The focus is finding the critical angle. Problem 11 asks us to calculate the critical angle for light traveling from glass to air, given the indices of refraction. We are also asked for the minimum angle at which total internal reflection will occur. The key concept is the critical angle formula, $theta_c equals arcsin, n_2, n_1 $. To solve this problem, we start by identifying the knowns. n1 equals 1.52 and n2 equals 1.00. The unknown is the critical angle, theta c. The critical angle condition is n1 times the sine of theta c equals n2 times the sine of 90 degrees. Since the sine of 90 degrees is 1, this simplifies to the sine of theta c equals n2 divided by n1. Plugging in the values, the sine of theta c is equal to 1.00 divided by 1.52, which is approximately 0.658. Taking the inverse sine gives a critical angle of approximately 41.1 degrees. Total internal reflection occurs when the angle of incidence exceeds 41.1 degrees.